All right, we're going to take a look at the design of a date class. It's not going to be a complete design, but just an illustrative design of certain concepts. And it's not so much the design per se that I want you to pay attention to, and maybe there are going to be some C++ language things that will be new to you. What I want you to focus on is how I go about designing and developing the class itself. So let's start off with a .h file, and the class I'm going to design is the date class, and of course it has public and private sections. And the type of date that I'm talking about is something that looks like this. 01/24/12, say for example. We have three elements here. We have, first of all, the month and the day and the year. All right. And so I'm going to store each individual components in these private data members. Now, usually when I start off, your public interface, and again, there are some fairly standard methods that you're going to need. First of all, we want a default constructor. We want an explicit constructor where someone can pass in values to the constructor itself. I'm going to implement a set method. So that we can change the values of the date object. And I'll just implement a simple get method just for illustration. So let's say, for example, get month. One of the things that I want to do here is use some of these methods for constant objects. So I have to declare this method as constant. I'm also going to want to have a very simple print method that I'm going to use for looking at date objects. And I want this to be able to use for any output stream, so I'm going to pass in some sort of an output stream here. And the default will always be cout. And this also will be a constant method because it does not change the internal state of the object. I'm going to overload just one operator as an illustration. And it is a binary operator, so we're going to pass in a date object. It's also a constant method. And I'm also going to overload the stream extraction, stream insertion operators. Here's the stream extraction operator. Just like that. Alright, so that's a good start on the design. Now, one of the things that I also want to do here is I'm going to implement data validation checks, right? I'm going to make sure that we get valid months, valid days, and valid years. And if there's a problem with the input, then I want to throw an exception. And the exception I'm going to throw is invalid argument. So any method or function that receives input is going to need to throw invalid argument. So that's going to be my explicit constructor, my set method, and then also my stream extraction operator. Just like that. So that's a pretty reasonable design. And now let's just finish off the .h file by adding in my preprocessor directives for preventing multiple header expansion. I'm also going to need some includes. And if you notice, I'm using things from IOStream. I am using, I get invalid argument from standard exception. And I think that is it. So I need to include IOStream. I need to include standard exception. And all of this is defined in the standard namespace. Now, if I want to check that my date class definition is syntactically correct, one way I can do that, and I'm going to have to do this sooner or later, is I'm going to implement date.cc, and I'll implement the methods below. I'm also going to need a main function and a main.h. Let me go ahead and create those. Maybe you've copied these over from other projects. I'm just going to create mine very quickly here. You know, in main, I know that I'm going to need IOStream. I'm going to catch exceptions, so I'm going to need standard except, and of course I'm going to be using the date class, so date.h. And then in main.cc, I can include main.h. Just like that. And one thing I forgot to do in main.h is just like that. And I have my makefile here all ready to go. So maybe I'll try to compile manually date.cc to see if my header file is fine. It is. And now I'll just try to compile the whole project. And all I'm doing here, since there is no code in date.cc, what I'm doing here is I'm checking the syntax of my date class. And so now I can start implementing these methods. And I'm going to start off with the default constructor. It's kind of the first thing you really need to do. And let's just say that my default constructor is going to set month to 1, day to 1, and the year to be 0. So that's just how I've decided my default constructor is going to work. So now I can actually test this by going into main.cc. Now I know that I'm going to be throwing some exceptions, so let me go ahead and set up my try block here. And I'm going to need a catch handler for invalid argument. And I'm not going to do anything fancy. All I'm going to do is just print out invalid argument. Just like that. And I'm also going to have a catch handler for any other types of exceptions. And we shouldn't get any of these, but it's always good just to have that handler in there. So let me just make sure all of this is syntactically correct. It is. But notice how I'm typing a little bit, saving, compiling, making sure that everything, and this is going to help me manage any compiler errors that I make inadvertently as I'm writing my code. So I've got an implementation of my default constructor here, and now I actually want to try that by calling it in main. And I'm going to create a date object here, just like that. And there we go. So when I run this, nothing is going to happen. How can I actually see that something is going on? Well, a print method is a very good way to get some insights into how, the internal state of your method. So I'm going to implement that now. And one of the things you have to remember is you declare your default parameter or default argument in the definition, but you don't repeat that assignment or that declaration in the method's implementation, and it's a constant method. So, what do I want my dates to look like? Now I'm going to be using this output stream, and by passing in an output stream as a parameter, I can use this print method to go to a file, or I can go to a console. We're just going to be looking at console output here. And so all I'm going to do is I'm going to print the month, followed by a slash, and the day, followed by a slash, and then, of course, the year. Just like that. And so go back into main, and now I can try the print method just like that. And what I'm doing here is I'm defaulting this to cout. Okay, so now I've got an error here, so I can look on line 12 to see what I did, and I forgot the scoping operator. So what happened here is the compiler thought I was implementing a function, and I was just, relying on these identifiers to be defined in the scope of the class, and they weren't. But by adding the scoping operator here, the class and the scoping operator, now compiler will know that this is a method of the date class and not just some print function. So now if I compile, it should be okay. And when I run this, you can see that the default constructor is working. Maybe I need to add a little something else here to my cout just to make the output kind of nice or better or easy to see. So that sounds good. That's a good start. Now the next method I'm going to implement is actually the set method, and we're going to use the set method to do our data integrity checks. And just starting off very easily, we're not going to implement this thing in just one fell swoop. We're going to increment it, or we're going to implement it incrementally, just to prove, or just to show the steps in development. So all I'm doing here is I'm taking the parameters and I am assigning them to the private data members, and just very quickly. Now I can go back into give a quick compile. Oops. Oh, okay. So right, I forgot to tell it that I need to throw an invalid argument here. Like that. Now we should be okay. And now I'm going to go in main.cc, and I'm going to use the set method by saying date.set 5513. Okay. So what I should see here, and this is one of the things that you should get into the habit of doing, is predicting the output of this program. I have a default constructed date here. I call print. I should see 110 just like I did before. Now I'm calling the set method, and maybe I'll change this just so to make sure that I'm getting the parameters in the right order into the right private data members. And then I should see here in the second print 5713. So that's what I am expecting to see, and sure enough, that's what I see. Now we need to implement some checks. So one of the things that I could do, for example, is I could change this to 15. That's not a valid month. I could change this to 45. That's not a valid number of days. And I could change this to -13, and that's not a valid year. And of course, right now I have no data integrity checks, and I want to make sure that when I store information in my data object, it's a legitimate set of values. So I need to go into date.cc and implement these data integrity checks. First thing I can do is I can ensure that month, the parameter, is between 1 and 12 inclusively. And if it's not in that range, then I actually want to stop the execution of the method and throw an invalid argument exception. So to implement that logic, what I'm going to do is I'm going to check to see if month is less than 1 or if month is greater than 12. And if that's true, then I want to throw an invalid argument. And the message that I'm going to provide to the constructor of the invalid argument exception is month is out of range. Or month, yeah, is out of range. And we could certainly write more descriptive messages, but this is good enough. So I also want to ensure that year is greater than 1, so I can implement that by saying if year is less than 0, then again I'm going to throw an invalid argument, and I can just say that year is out of range. So the only thing that's left is to verify that the date is appropriate. And I want to make sure, I'm not going to handle leap years or things like that, but I do want to make sure that for January, for example, we have 31 days, and for February we only have 28 days. So to do that, I'm just going to use a switch. And of course I'm switching on the month to figure out what month it is. And as you know, if month is 1 or if month is 3 or 5 or 7, 8, so these are all the months that have These are all the months that have 31 days. So now I can just check to see if date is less than 1 or if date is greater than 31, then I know that this is an invalid date, and I can conclude that date is out of range, or day is out of range. I can just do the same thing with the other months. So the months that have 30 days are April, June, September, and November. Change that to 30. And don't forget my break. And then finally we can worry about February. Just make sure my style is reasonable. Okay. Great, so here is our switch that makes sure that if we have a month with 31 days, we get a day check to make sure it's within that range. Here are our months with 30 days, And then, of course, February only has 28 days. All right. So let's make sure that compiles. And let's go back into main.cc and test this. So before, maybe I'll test it on a good date first. Make sure that it's working well for that. And so what I should see is similar output and normal termination. So I can compile this, run it, and I get 5/15/13. Now if I pass in invalid arguments, the set message should throw the exception down to here. I should see the output, and then I'll terminate. And that's exactly what happens. So year is out of range. And the reason it's saying year is out of range is because that's the check. It's the first check I did. So now I'm going to replace 13 and run that. And now it's telling me that my month is out of range. Remember, that was the second check we did. So I'm going to make this 12, run that. Now I should see that the day is out of range. And I'll give it a reasonable date. And that's a valid date. But, again, notice how I'm gradually testing, implementing, testing, compiling, and gradually building up this date class. So what do I want to implement next? One thing I am going to do is I'm going to go back to here, and I am going to take advantage of this set method that I have already implemented. And this may seem like a silly thing to do, but somebody could come in here and, who knows, mistakenly type something in. I want to make sure that even in my default constructor that these default values are going through the checks. So I'll get rid of that. Now let's implement my explicit constructor. And this is going to throw an invalid argument. And all I have to do here, now that I've implemented my set method, is just pass these values to the set method. So let's try this. Well, first of all, let me give it a quick compile. And let's go into main.cc. And now I actually want to check to see if I'm getting my default constructed object. There we go. And now I'm going to do exactly the same checks that I did before. I'm going to make sure that all my checks are being applied. So again, the year is out of range, so I'll bring the year in range. Now I should see that the month is out of range, so I'll give that a legitimate value. And now I have a legitimate date. Let me just make sure, put this out of range. And day is out of range. Okay, so now my explicit constructor is working properly. So now that we have our explicit constructor working, we can focus our attention on some of the other methods. So let's take a look at the overloaded equality operator. And this will let us check to see if two dates are equal. And all we have to do to implement this method is make sure that the years are the same, the months are the same, and the days are the same. One way to do that is to simply say, okay, if this year is equal to the parameters year, the date that's passed in the parameter, and the month is also equal to the parameter's month, and of course the day is equal to the date's day. If that's true, then we can return true. Otherwise, we want to return false. See if that compiles. Yeah. And another way of writing this is the truth, the return value is actually just the value that this expression evaluates to. So I could also write this like this. And so if this is false, if this expression is false, then it returns false. If this expression is true, then it returns true. So now let's go back into main and check to see if that method works. Just some simple code to make sure that the method is working. And so these two dates are equal, and we see that it prints equal. Now if I change this and run that, they're not equal. And maybe I just make sure that it's taking into account each individual thing. I actually don't need to do that because of the way that I've written my expression, but we'll just go ahead and go through the different options to make sure. Excellent. So now we have a working equality operator for dates. And, we could finish this off with not equals and with less than, equal to, and the other relational and equality operators if we wanted to, but this is just illustrating. So the next thing I want to do is implement the stream insertion, stream extraction operators. And what these will let me do is they will let me read dates from an input stream. In this case, it's the console input. And I'll be able to write dates to an output stream. In this case, it will be cout. So I want to implement these methods. Or I'm sorry, I want to implement these functions. And the stream, let's do stream insertion first. And so I'm returning a reference to an O stream. And I'm passing in an O stream. And I'm also passing in a date object. One thing I could do here is I have a print method, so I could just call the print method of the date object and then pass in the string. This actually will work. And then I have to return out. And for the input stream, I'm going to do something just very simple, and then we'll look at some of the problems with the implementation and see if we can fix that. So think about the format of a date, right? So it's an integer, say 4, a slash, an integer, say 5, and then another integer, 13. So the input statements, I'm going to use the variable character ch to read the slashes, and I'm simply going to extract a month, and then I need to read a character, which should be the slash, and then I'm going to read the day, and then the next character, which is a slash, and then I'm going to read the year, and then I'll return my string. So that's an implementation of my stream extraction operator. So let's see if this compiles. Oops. So it says that in my insertion operator, so 57, I know what I forgot to do. No, I did do that. What the heck is going on? One thing I forgot to do is I forgot to declare that iStream throws an invalid argument. I don't know if that's the problem. It shouldn't be. Yeah, I'm passing in a date object. I've declared that it's a friend. And I say d.mm, d.ch. I wonder if the absence of the throw. Nope. Huh. What am I doing wrong? Oh, okay. I see what I did. I actually have my the function names in were wrong. Okay, maybe you saw that. Okay, so now we should be compiling. All right, so let's look at our main.cc again. And so what I'm doing here is let me print the constructed date D1. Let me just change this D1 to date just so we got one. So I've got my constructed date D1, so this should print out 12/15/13. And then I'm going to enter a date. Maybe I'll give a prompt here. Enter a date. And then I'm going to enter a date, and then it'll print out that new date. So there's my date. And to enter proper date, I'm going to enter 9/9/10. And you can see that it read it, and that is my new date. So one thing though, one problem with the implementation of my stream extraction operator is that I can actually enter just about anything and it will accept it as a date. So for example, any 3 integers separated by any characters will be processed as a valid date. And you can see that that's problematic, and now I've got something that really is not a valid date. So I need to do a couple of things here. Number one, I need to pass the values that I read into my set method to do the data integrity checks. The other thing I need to do is I need to make sure that these characters that I'm reading are actually slashes. So let's go in and take a look at how we're going to do that. So let's focus on the data integrity checks first. First thing I'm doing is I'm reading directly into these private data members, so that's a big problem. The way to fix this is to declare local variables, integers in this case, and I'm going to read into my local variables first, not directly into the private data members of the data object. And now what I'm going to do is, now that I've read them, I'm going to pass them into the set method of the date class. That will do my data integrity checks for me. If there's a problem, it will throw an invalid argument. So let's try that. So now if I type in 2, 3, 12, everything should be fine. But if I type in -2 or -3, 45, and -13, I should get an invalid argument exception. So let's go back in and type -3, 45, and a valid date this time. Now it's going to tell me the month is out of range. Now I can type in a valid month, and now it will tell me that the day is out of range, and so finally I can type in a legitimate date, and it accepts it. However, the slashes are still a problem. I'm doing my data integrity checks on my day, month, and year, but I can still type in any character instead of the slashes, and it will still read that. So as you know, what happens when you read something that's not the proper format, the fail bit on the string gets set. So that's how we're going to do this. So if I go into date.cc, what I need to do is I need to make sure that the character I read here and the character that I read here are both slashes. So to implement that, I'm going to read into two different character variables. So I'm going to read ch1 here, and I'm going to read ch2 here. And actually both of those have to be slashes. So if character 1 is not a slash, or if character 2 is not a slash, then I know that I've got a problem, and I'm going to set the state of my input stream, and I'm going to set the fail bit, just like that. And then, if the format is correct, then I'm going to try to set the values of the date object. So let's see if that compiles. And we got to change main.cc a little bit to, and I can check if the fail bit has been set by using the fail method, and I can say fail bit set. Otherwise, I'll print the date. So let's run that, see what happens. Okay, so now I'm going to enter a date, and I'll enter the same one that I did before. Whoops. Or a similar one. And now you can see that the fail bit has been set. So let's try 2/2 exclamation 12. Fail bit is set, and so finally if I enter 2/12, it gives me, oh sorry, 2 messed up there. Now it gives me a legitimate date. So just to go over my implementations again, here I've got a default constructor. I'm passing these values to my set method. Explicit constructor, I have a print method. Then I have my set method that's making sure that all the values are in range before I actually set those values to the private data members. Here's a simple implementation of an overloaded equality operator, and a simple implementation of a stream extraction, a stream insertion operator. And what I'm doing here is I'm taking advantage of a print method that I've already implemented. And then finally I've got my stream extraction operator that reads into local variables before passing that to the set method that performs the data integrity checks. And I'm also doing a check on the format of the date to make sure that I'm getting slashes. And if that's not true, then I set the fail bit. Alright, so here we are again. And I just need to finish up one more thing, and then I'm going to demonstrate how constant objects work with constant methods. And then we'll look at reading a series of dates from a file. So the last method I need to implement is my get method. And I'll implement that right here. And all that's just an example. All that's going to do. Actually, let me look to see what the name of that method was. Get month. So that's actually the method I need to implement. That also is going to be constant. And as you know, all get methods do is return the associated property or attribute or value of the data member. So here we'll try that. And again, we can go into main.cc and try this out, and I'll get rid of all this stuff. And so this should just print 15. Whoop, oh, month, yeah, month is 12, so it prints 12. So now for constant objects, let's say, for example, instead of a variable date, I want a constant date, and that means that I can't actually change either the month or the day or the year of that object once it's constructed. And so this works, right? So the stream extraction operator doesn't change the state of the date object. Get month doesn't change the state of the object. And that's the purpose of the constant keyword in the implementation of these methods. The constant keyword here, the constant keyword here, the constant keyword here. It signals that this is a method that can be used with constant objects. So now what would happen if we tried to call the set method? So now here, if I try to change the date to something else, when we compile, you can see that I'm passing in the constant date, and it's going to discard the qualifier, which is essentially a signal that I've declared a constant date and I'm passing into the set method, which is not constant, and so I've got a problem here. So I either need to, in main, I either need to get rid of this qualifier or get rid of the call to the set method. So that's how constant objects work along with constant methods. So now let's say, for example, I want to read some dates out of a file, and I'm going to create a file called dates.dta, and I can just type in a bunch of different dates in here. Just like that. And now I want to open and read those dates from that file. So the first thing I need to do is I need to include the fstream library, which is for file streams. And now in main.cc, I am going to use a default constructed date for reading. And all I'm going to do is open the file, read the dates in succession, and print them out to the console. So I need to create an IF stream that I'll call fin using dates.dta, so that's going to open that file. Once that file is open, I'm going to read a date, and as long as the file stream evaluates to true, then I am going to print a date to the console, and I will keep reading dates until, in this case, I reach the end of file. And as you can see, I read the dates from that file and then printed them to the screen.